A colossal stone lion hides a secret in its weathered skin. The Great Sphinx of Giza may be thousands of years older than the pharaohs who supposedly built it. By the end of this exploration, you will see how the very stone of the monument challenges our entire historical timeline. We will investigate why its deep scars point to a forgotten age of rain, and how the bedrock itself whispers of a civilization lost to time. What forgotten story does the oldest statue on Earth truly tell? For centuries, the official story has been beautifully simple. The Great Sphinx, we are told, was carved from the living bedrock around 2,500 years before the Common Era. It was a monumental portrait of the pharaoh Khafre, a guardian of his pyramid complex, and a timeless symbol of royal authority fused with the power of the sun god. This attribution rests on a foundation of archaeological context, the arrangement of the Giza plateau, and the stylistic echoes found in statues of the king. It is a narrative taught in textbooks and repeated in documentaries, placing the Sphinx firmly within the golden age of Egyptian pyramid builders. Yet standing before the monument, a quiet but persistent anomaly challenges this comfortable timeline. Look at the stones. The Sphinx body is a tapestry of deep, undulating grooves and severe erosion, its surface worn into soft, rounded contours. Now turn your gaze to the nearby mortuary temples and the massive limestone blocks of the pyramids themselves, structures officially dated to the same brief period. Their surfaces, while ancient, show the sharp angles and precise cuts of tool marks, weathered by wind and sand in a completely different, far less aggressive pattern. This stark visual contradiction is the first crack in the story. If all these monuments were exposed to the same desert climate for the same 4,500 years, why do they bear such dramatically different scars? This simple, observable fact refuses to be ignored, and it pushes the investigation beyond archaeology and into the realm of geology, to a time when the sands of Giza were washed by a very different kind of storm. The Sphinx itself offers the first and most profound geological clue. Its weathered hide tells a story not of dry desert winds, but of relentless, pounding rain. To understand this, we must look past the monument's iconic form and examine the very stone from which it was carved. The Sphinx sits within a deep, excavated enclosure, its walls rising dramatically around it. The surface of these walls and the lower portions of the Sphinx body are scarred by a series of deep, vertical channels and undulating, rounded hollows. These are not the sharp, angled grooves left by tools or the pitted, sand-blasted surfaces seen on the nearby pyramids. This is a softer, more flowing kind of damage, as if the stone had been melted or deeply dissolved over a very long time. For decades, this peculiar erosion was simply accepted as part of the Sphinx's ancient mystery, until a geologist named Dr. Robert Schoch brought a fresh pair of eyes to the problem. Trained to read the language of rock, Schoch saw something in those weathering patterns that archaeology had overlooked. He noted that in the hyper-arid climate of the Sahara, which has persisted for over 5,000 years, the primary erosive forces are wind and sand. Wind-blown sand acts like a gentle but persistent abrasive, scouring surfaces and creating a distinct cross-hatched or pitted texture. It does not carve deep, vertical runnels. What does create such patterns? Moving water, specifically heavy rainfall cascading over exposed rock faces over hundreds or even thousands of years. The runoff gathers, follows natural weaknesses in the stone, and gradually, inexorably cuts downward, creating those signature vertical channels and rounded, scalloped contours. Schoch's conclusion was as simple as it was revolutionary. The most severe and defining erosion on the Sphinx enclosure was caused by water, not wind. This meant the monument had to have been standing exposed during a period when the climate of the Giza plateau was significantly wetter, a time of regular, heavy rains. According to paleoclimatological data, the last such rainy period in that region ended around the middle of the 4th millennium before the Common Era. That is a full 1,000 to 2,000 years before the traditional date for the Sphinx's construction, so the stone itself seems to be whispering a different timeline. If the Sphinx was carved in the dry era of the pharaohs, it should bear the marks of that dry era. Instead, it wears the scars of a much older, forgotten climate, a time when the desert was green and the skies opened up, patiently sculpting the world's most famous monument long before history as we know it began. Dr. Scott's rainwater hypothesis presents a powerful argument, but it raises an immediate and critical question: when exactly did this great deluge happen? To answer that, we must leave the Sphinx enclosure for a moment and journey into the deep past of the Sahara itself. The story is written not in hieroglyphs, but in layers of mud, ancient lake shores, and the silent testimony of fossilized pollen. What this evidence reveals is a landscape almost unrecognizable from the desert we see today. For thousands of years, roughly between 10,000 and 5,000 years ago, North Africa was in the grip of a climatic phase scientists call the Neolithic Subpluvial. This was the Green Sahara. During this epoch, seasonal monsoon rains pushed far north, transforming the arid wastes into a vast savanna dotted with lakes and crisscrossed by rivers. Herds of animals grazed where there is now only sand, and human communities thrived in a much more hospitable environment. This pluvial or rainy period did not end abruptly, but it faded as the Earth's orbital cycle slowly shifted. The rains retreated southward, the lakes dried up, and the desert began its relentless advance. By around 3,000 years before the Common Era, the hyper-arid conditions we associate with ancient Egypt were firmly established. This climatic timeline creates a fascinating and very tight window. The type of deep, channeling erosion seen on the Sphinx requires prolonged exposure to substantial rainfall. That kind of weather simply did not exist at Giza after the desert returned. Therefore, if the water erosion is real, the logical conclusion is inescapable. A significant portion of the Sphinx's weathering must have occurred during that Green Sahara period, meaning the core structure was already standing, exposed to the elements for centuries if not millennia before the dry era of the pharaohs. This shifts the monument from a creation of a known civilization into a relic from a much older, perhaps forgotten chapter of human history, a sentinel that watched the very desert being born around it. This brings us to a third and perhaps most visually compelling geological clue. Look closely at the Sphinx itself, not as a unified statue, but as a sculpture made from two very different kinds of stone. The massive body, with its deeply recessed flanks and the famous pores, is carved from a layer of limestone that is relatively soft and more prone to erosion. The head, however, is fashioned from a much harder, more durable stratum of rock. According to the traditional timeline, both of these sections have been sitting side by side, exposed to the exact same desert climate for the same 4,500 years. So logically, they should show a similar degree of wear, just shaped by the different resistances of their stone. But that is not what we see. The contrast is startling. The body of the Sphinx is profoundly weathered, with those deep vertical channels and cavernous hollows that suggest immense age. The head, while ancient and damaged, retains far more of its original sculpted form. The erosion there is of a different, less aggressive character. This phenomenon is known as differential weathering, and it is a powerful tool for geologists. When two rock types of different hardness sit together, the softer rock wears away faster, revealing the more resistant stone. But here's the puzzle. The differential weathering on the Sphinx is extreme. It suggests the softer stone of the body was subjected to intense erosive forces for a very, very long time, while the harder stone of the head experienced a shorter or different period of exposure. This creates a serious problem for the standard chronology. If the entire monument was carved around 2500 B.C.E., then both the hard and soft limestone should have only experienced about 4.5 millennia of primarily wind-based erosion. That amount of time in a dry climate simply would not produce such a dramatic difference in wear. The body looks, for lack of a better word, older. It looks like it has been out in the elements being shaped by water for a duration that the head did not fully share. This leads to a fascinating and controversial possibility. Could the original Sphinx have been a much older natural rock formation, perhaps a yardang sculpted by wind and water that was only later recarved? Might the lion's body be a relic from a wet, ancient past, while the pharaonic head is a later restoration, a recasting of an already ancient guardian in the image of a new king? The stone itself seems to be telling a story in two distinct chapters, written millennia apart. This story of two stones is not the only architectural whisper from the past. To find the next clue, we must look down at the very feet of the Sphinx. Encircling its massive paws and lower body is a vast masonry skirt, a patchwork of thousands of limestone blocks. These are not part of the original sculpture. They are ancient restoration blocks, placed there to repair and reinforce the monument after it had already suffered catastrophic damage. The official archaeological dating of this restoration effort is fascinating. Most Egyptologists attribute this major repair campaign to the pharaohs of the Old Kingdom, possibly even to Khufu's own son, Menkaure. This places the restoration work firmly in the 26th century before the Common Era. Now, here is where geology delivers a stunning piece of chronological evidence. When researchers examined the interface between these Old Kingdom repair blocks and the original core body of the Sphinx, they noticed something remarkable. The surface of the original rock, the surface that had been hidden and protected by these blocks for over 4,000 years, was not fresh and sharp. It was already deeply, profoundly eroded. The weathering profiles, those vertical channels and rounded hollows, matched perfectly with the exposed sections above. This means the severe erosion that had so weakened the monument's base had already happened in full before the Old Kingdom masons arrived with their new stones. Think about that timeline for a moment. If the Sphinx was built by Khufu around 2500 B.C.E., and his son was repairing it just decades or a century later, that leaves an impossibly narrow window. In just a few generations, the monument's base would have had to weather so severely that it required a massive, urgent restoration project. Yet the climate of that era was already dry. Wind and sand simply do not work that fast, nor do they create that specific type of deep, water-cut erosion. The stone tells a different story. It says the Sphinx was already ancient by the time of the Old Kingdom. It had stood through a long, rainy epoch that sculpted its deep wounds, and only then, centuries or even millennia later, did a civilization with the means and the will find this weathered giant and begin the work of saving it. The restoration blocks are not just repairs, they are a timestamp. They mark the moment a younger civilization encountered a relic from a world they had already forgotten, and in their efforts to preserve it, they accidentally preserved the proof of its true, staggering age. Of course, the stone story is not without its critics. For every voice that sees ancient rain, another sees a more familiar desert wind. The mainstream archaeological and geological perspective offers a powerful counter-narrative, one that seeks to explain the Sphinx's unique weathering without rewriting history. This argument centers on the very nature of the Giza plateau itself. The bedrock here is not a uniform block, but part of the Mokattam Formation, a complex layer cake of limestone deposited over millions of years. Some layers are soft and chalky, others are hard and dense, and they are stacked at slight angles. Proponents of the traditional timeline argue that this geological complexity is the true key to the puzzle. When wind loaded with abrasive sand blows across these uneven surfaces for millennia, it will naturally scour the softer layers more aggressively, retreating them back and leaving the harder layers more prominent. This process, they suggest, could create recessed hollows and vertical features that might, to an untrained eye, resemble water channels. Furthermore, they point out that the Sahara's climate has had minor fluctuations. Even in arid periods, occasional, violent thunderstorms can unleash torrents of water. A single, catastrophic flash flood rushing through the Sphinx enclosure could carve significant grooves, and the daily condensation of dew on the cold stone could slowly dissolve the surface over centuries. From this viewpoint, the Sphinx's erosion is a testament not to a lost green age, but to the relentless, varied forces of the Egyptian desert acting upon a particularly vulnerable and complex piece of stone. The monument looks different from the pyramids simply because it is carved in situ from a problematic rock stratum, while the pyramids were built from quarried blocks of better quality stone. This explanation keeps the Sphinx firmly within the age of the pharaohs, a product of known forces acting on a challenging canvas over a known span of time. It is a compelling argument for geological normality, reminding us that extraordinary appearances do not always demand extraordinary timelines. But the story of the Sphinx is not only written on its surface. To find the next layer of the mystery, we must listen to the ground beneath our feet. The Giza plateau hums with a silent energy, a geological fingerprint that modern science is only beginning to map. Beyond the visible erosion, the very subsurface of this ancient site may hold the most startling clues of all. In recent decades, researchers have turned to non-invasive technologies like seismic refraction and ground-penetrating radar, sending pulses of energy deep into the bedrock to paint a picture of what lies hidden below. These preliminary surveys have returned intriguing, if not yet definitive, whispers. The data hints at anomalies beneath and around the Sphinx, unexpected variations in density, potential cavities, and what appear to be tunnels or conduits running through the limestone. One notable survey suggested the possibility of a large, rectangular chamber deep beneath the Sphinx's front paws, while other readings indicate networks of fissures or passages that seem too regular to be entirely natural. Now, it is crucial to state clearly that these findings are not conclusive proof of anything. They are echoes in the stone, requiring much more extensive and coordinated study to interpret. Natural fractures, pockets of different rock, or even voids left by ancient groundwater can create similar signatures. But if these anomalies were to be confirmed by future, rigorous geophysical investigation, their implications would be profound. Imagine for a moment that beneath the Sphinx lies not solid bedrock but a labyrinth, not a tomb necessarily, but a worked architectural space. This would fundamentally change the monument from a solitary statue into the capstone of a much larger, integrated complex. Its construction would then represent not just the carving of a likeness, but a massive engineering project involving deep excavation and subterranean planning on a scale that feels out of step with a single pharaoh's commemorative project. Such a discovery would force us to ask a new set of questions. Were these spaces part of the original design from a much older, forgotten culture? Could the Sphinx itself be a marker, a guardian placed above a sacred or functional underground network? The possibility reframes the entire site. It suggests the plateau was chosen not just for its good stone, but for a pre-existing geological feature, a natural cave system or spring, perhaps, that was then dramatically modified and monumentalized. This transforms the Sphinx from a beginning to a continuation, a later chapter in a story that started deep underground, in a time when the desert was green, and the purpose of this place was something we can now only try to hear in the faint echoes from the stone. The debate over wind and water is ultimately a question of chemistry. To move beyond surface observations and into the realm of proof, we must shrink our perspective from the monumental to the microscopic. This is the domain of petrography, a scientific discipline that studies the very fabric of stone. Imagine taking a sliver of the Sphinx's limestone, thinning it to a translucent slice, and placing it under a high-powered microscope. At this scale, rock is not a solid mass but a dynamic archive. It is a tapestry of mineral crystals, fossil fragments, and the tiny pore spaces between them. Every weathering agent, whether wind-driven sand or cascading rainwater, leaves a unique fingerprint on this microscopic landscape. Water, especially when slightly acidic from dissolved atmospheric gases, does not just wear rock away. It invades it. It travels along the boundaries between crystals, dissolving certain minerals and carrying them away in solution. This process, called leaching, leaves behind a telltale signature. It can create hollowed-out voids where crystals once were, or it can deposit new, secondary minerals in the pores as the water chemistry changes. The crystal structure itself can be altered, showing signs of chemical transformation under the relentless, patient work of hydration and dissolution. Wind and sand, by stark contrast, act more like a physical abrasive. Their signature is one of mechanical force, not chemical change. They grind and polish the surface, fracturing crystal edges and creating a layer of crushed, fine-grained dust called rock flour. They do not typically penetrate deep into the rock's interior to rearrange its chemistry. They scar the surface while water rewrites the story from within. A comprehensive petrographic analysis of samples taken from the deeply weathered sections of the Sphinx enclosure, compared to samples from the less weathered pyramids or from known wind-scoured desert surfaces, could theoretically settle the argument. It could identify whether the internal architecture of the stone shows the deep chemical alterations consistent with prolonged water exposure, or the shallower, mechanical damage of sandblasting. While such a definitive, large-scale, and peer-reviewed petrographic study focused solely on the Sphinx's erosion mechanisms remains a goal for future research, the potential is immense. This technique offers a path beyond interpretation and towards empirical data. It is a way to listen to the stone's own testimony, written in a language of crystals and chemistry, to finally answer the question that has echoed across the plateau for generations. Did the desert wind shape this guardian, or was it the memory of a forgotten rain? The stone of the Sphinx does not exist in isolation. To truly understand its age, we must see it not as a solitary statue, but as one piece in a vast geological puzzle spread across the Giza plateau. This is where the science of stratigraphy becomes our most reliable detective. Stratigraphy is simply the study of rock layers, the pages of Earth's history book. The plateau is made up of the Mokattam Formation, a sequence of limestone layers deposited over millions of years. The Sphinx is carved directly from one specific chapter in that book, a stratum geologists call Member 2. This same layer of stone, this exact page of history, was also quarried by the ancient Egyptians to build other structures. The Kaffa Valley Temple, located right in front of the Sphinx, and the so-called Sphinx Temple, situated directly beside it, are both constructed from massive limestone blocks. And crucially, many of these blocks were cut from that very same Member 2 layer. This gives us a perfect, controlled experiment. Here we have two types of stone from the same source, exposed to the same desert climate for the same amount of time, according to the traditional timeline. On one side, we have the Sphinx, its body carved in place from the living Member 2 bedrock. On the other, we have the quarried blocks of Member 2, shaped and stacked to build the temples. If all were created around 2500 BCE, their weathering should be broadly comparable, allowing for differences between in situ rock and worked blocks. Yet when you place them side by side, the difference is not subtle, it is profound. The core body of the Sphinx shows that deep, rounded, undulating erosion with vertical channels cut several feet into the stone. The quarried blocks in the temples, while ancient and worn, display a sharper, more angular degradation. They show the pitting and scouring of wind and sand, not the deep dissolution of water. This stratigraphic correlation is a quiet but powerful argument. It suggests the Sphinx's core stone was exposed to the elements and subjected to aggressive weathering agents for a much longer period than the temple blocks were. The temples, built from freshly cut stone, only began their aging process when they were assembled. The Sphinx, if it is older, would have already been ancient, its weathering profile already deeply established, while the temples were being built around it. Think of it like two pieces of wood from the same tree. One has been left outside in the rain for a century, its grain raised and soft, its surface deeply grooved. The other was sanded smooth and placed under a porch 50 years ago. They are the same material, but they tell very different stories about their exposure to time and weather. By reading the layers, this geological detective work builds a contextual case. It tells us that the story written on the Sphinx's stones is from a much earlier chapter than the one written in the temples that sit at its feet. But water's work is not always written in the sky. Sometimes the most profound erosion comes not from the rain above, but from the silent, rising damp below. To fully unravel the Sphinx's weathered skin, we must look down into the very earth it stands upon and consider a geological actor often hidden from view. This is the story of ancient groundwater and a quiet, powerful force called capillary action. For millennia, the lifeblood of Egypt has been the Nile River. Its annual floods did more than fertilize fields. They directly influenced the water table beneath the Giza plateau. Historical and geological records suggest the Nile's height has fluctuated dramatically over the ages, sometimes flowing much higher and closer to the monuments than it does today. During these high water periods, the local groundwater level would have risen correspondingly, effectively turning the lower layers of the Giza bedrock into a giant stone sponge. The limestone of the Sphinx enclosure is naturally porous, filled with tiny, interconnected spaces. When groundwater saturates this stone, it does not sit still. Through capillary action, the moisture is drawn upward, defying gravity, moving through these microscopic channels. Think of it like a paper towel dipped in water. The liquid climbs steadily through the fibers. Now, this rising water is not pure. It contains dissolved minerals and salts picked up from the surrounding geology. As this saline solution travels upward through the Sphinx base and walls, it eventually reaches a point where the stone is drier and warmer, near the surface. Here, the water evaporates into the desert air, but the salts it carried cannot evaporate. They are left behind, crystallizing inside the very pores and fissures of the limestone. And this is where the destruction happens. Salt crystals, as they form, expand with tremendous force. This expansion acts like a microscopic wedge, relentlessly prying apart the mineral grains that hold the stone together. Over countless cycles of wetting and drying, this process, known as salt weathering, literally explodes the rock from the inside out. It creates a soft, crumbly, deeply pitted surface that can then be more easily scoured away by wind or washed away by even occasional rain. This mechanism is especially potent at the base of structures, right at the groundwater zone, and it produces a rounded, cavernous type of erosion that can look remarkably similar to water runoff patterns. The significance of this is profound. It introduces a powerful and complicating factor into the erosion debate. The deep, rounded hollows on the lower Sphinx could be the product not only of direct rainfall from a wet climatic period, but also of millennia of this invisible, subterranean attack. It means the erosion clock might have been ticking in two ways at once. the monument could have been weathered from above by ancient rains and simultaneously from within by the rhythmic pulse of the Nile's forgotten floods. This doesn't necessarily invalidate the older Sphinx hypothesis, but it adds a layer of intricate complexity. It suggests that even if the Sphinx were younger than some theories propose, its exposure to a dramatically different hydrological environment, a time when the water table lapped at its pores, could have accelerated its aging, creating a visage of immense antiquity through a combination of forces both seen and unseen. The stone story, it seems, is written not just by the sky, but by the hidden rivers flowing silently beneath our feet. A final clue lies not in the stone, but in an ancient text. In the mid-19th century, archaeologists working at Giza uncovered a remarkable artifact known as the inventory stela. Carved from limestone, this stela presents a narrative that directly contradicts the standard historical timeline. It claims that during the reign of the pharaoh Khufu, the father of copper, the great Sphinx was already standing on the plateau. According to the inscription, the monument was not built by Khufu, but was discovered by him, already ancient and damaged. It even specifies that the damage was caused by a lightning strike, a detail that feels strangely specific for a mere legend. The stela states that Khufu then ordered repairs to the Sphinx and its surrounding temples, treating it as a sacred relic from a bygone age. For mainstream Egyptology, this document presents a serious problem. Based on the style of its hieroglyphs and its archaeological context, the stela itself is dated to the late period of Egyptian history, around 2,500 years after the time of Khufu. Because of this, scholars have long dismissed it as a pious forgery, a piece of religious propaganda created by later priests to connect their temple to the glorious age of the pyramid builders. It is seen as a historical fiction, not a factual record. Yet, when viewed through the lens of the geological evidence, this ancient text takes on a hauntingly different character. If the core body of the Sphinx truly bears the scars of a much older, rain-soaked climate, and if its base was already crumbling when the Old Kingdom pharaohs restored it, then the story on the inventory stela stops looking like a forgery and starts to sound like a distant echo. It could be a garbled, millennia-later memory of a genuine historical truth. Imagine a priest 2,500 years removed from the Old Kingdom, trying to make sense of the same monument we study today. He sees a colossus of unimaginable age, bearing repairs attributed to Khufu. The oral traditions of his temple might have preserved a kernel of the real story, that the Sphinx was already ancient when the Great Pyramids were new. In trying to formalize that tradition, he might have inscribed a version of events that, while chronologically misplaced in its creation, contained a seed of geological reality. The stela, then, is not a lie but a palimpsest. It is a later text written over a much older memory. It suggests that the Egyptians of the late period themselves believed the Sphinx predated their most venerable ancestors. This creates a fascinating convergence where geology and legend whisper the same unsettling possibility. The stone says the monument is older than we thought, and an ancient text, long dismissed, quietly agrees. The geological evidence, if accepted, does more than just adjust a date. It shatters a narrative. A Sphinx carved not 4,500 years ago, but 7,000 or even 9,000 before the Common Era, does not fit into the world history we have been taught. This monument would belong to a time so distant it predates the very concept of Egypt itself. We are no longer in the age of grand pharaohs and pyramid builders, but in the deep twilight of the Neolithic, a time of early farming communities, stone tools, and settlements just beginning to root themselves to the land. This is the profound and unsettling implication. If the stone is telling the truth, then the story of the Sphinx is not an Egyptian story at all, at least not in its origins. It becomes the legacy of a lost world. Imagine the Nile Valley around 7000 BCE. The climate is still in its wet phase, lush grasslands stretch where desert now lies, dotted with seasonal lakes and teeming with wildlife. Small, scattered communities of people live here, hunters and gatherers transitioning to early agriculture. This is the backdrop against which the traditional timeline places simple, village-level societies. Yet, according to the geological argument, in the midst of this landscape, a project of staggering ambition was undertaken. A workforce guided by a clear vision excavated 100,000 tons of bedrock to free the form of a colossal lion from the earth. This was not a small communal shrine. This was a generation-spanning endeavor requiring not just labor, but advanced planning, a sophisticated understanding of stone, and a powerful, unifying purpose. The sheer scale of the task implies a level of social organization, technical skill, and long-term cultural memory that mainstream archaeology does not typically attribute to Neolithic societies in that region. It suggests a precursor civilization, one with the capacity for monumental architecture long before such feats were thought possible. This leads to a captivating and speculative question. Who were they? We have no written records from such a time, no king lists or administrative texts. Their identity is written only in the monument they left behind, and perhaps in the cultural DNA of those who came after. Some researchers propose that this lost culture was not a single, centralized empire, but a highly advanced, spiritually unified society that flourished during the Green Sahara period. Their mastery might have been less about bureaucracy and more about a deep, symbiotic relationship with their environment and a profound astronomical or mythological knowledge. The Sphinx, aligned precisely to the cardinal directions and possibly to specific celestial events, could have been their ultimate statement, a permanent marker of their understanding of the cosmos and their place within it. Then, as the climate changed and the desert encroached, this culture may have fragmented, migrated, or faded from history. Their great monument, however, remained, slowly being buried by the advancing sands. Centuries, then millennia, passed. New peoples moved into the Nile Valley, coalescing into the early dynastic cultures we recognize as ancient Egypt. One can envision a moment, perhaps during the reign of an early pharaoh, when the shifting dunes partially revealed a gigantic stone head emerging from the earth. To these new inhabitants, it would have been a miraculous discovery, a divine artifact from the time of the gods, a Shesep Ankh, a living image waiting for them. They would have seen its leonine form, a symbol of solar power and protective strength, and recognized its sacred potency. In a profound act of cultural adoption, they may have claimed it, restored its weathered body, and recarved its head into the likeness of their own king, linking their new dynasty to the primordial authority of this ancient land guardian. The original builders were forgotten, their story erased by time and sand, but their masterpiece was given a new name and a new life, becoming the Great Sphinx of the Pharaoh coffer. This is not to diminish the achievements of dynastic Egypt, but to potentially expand our understanding of human cultural development. It suggests that civilization, in the sense of large-scale, coordinated artistic and engineering expression, may have deeper and more complex roots, with knowledge and traditions being passed down, adapted, and reinvented across vast stretches of time. The Sphinx, then, stands as a silent bridge between two worlds, a testament not to one civilization, but to the long, layered, and often mysterious journey of human ingenuity itself. The Sphinx presents more than a chronological puzzle. It poses a profound engineering challenge. To carve a creature of such scale directly from the bedrock required a mastery that feels almost out of time. We are not looking at a simple sculpture, but at a monumental act of reverse architecture. The builders did not assemble the Sphinx block by block. They began by excavating a massive trench around a natural limestone outcrop, a negative space that defined the monument's positive form. This quarrying operation alone was a feat of logistics and planning, requiring the removal of an estimated 100,000 tons of stone. but the true sophistication lies in what happened next. With the rough shape isolated, the sculptors then had to work inward, carving the detailed leonine body, the massive paws, and the iconic head from the top down, all while maintaining perfect proportions on a scale they could never step back to see in full. This demands an advanced understanding of surveying, of geometry, and of stone itself. It implies the use of sophisticated measuring cords, sighting poles, and perhaps even early forms of scaffolding and lifting technology to manage the debris and allow access to the upper sections. The precision of the excavation walls, the symmetry of the form despite the stone's natural flaws, all speak to a culture with a deep, practiced tradition of large-scale stonework. If we accept the geological argument for a much older date, this capability becomes a staggering paradox. It places this advanced engineering project not in the Bronze Age, but deep in the Neolithic, a period we traditionally associate with polished stone tools, early agriculture, and village life, not with 100,000-ton quarrying operations. The Sphinx, in this light, is not just an anomaly, it is an outlier. It stands as a solitary data point suggesting a peak of technological and organizational skill that our current historical models do not account for in that era or in that place. This forces a difficult but necessary question. Where did this knowledge come from, and where did it go? One possibility is that it was developed independently by a local, sophisticated culture during the wet Neolithic period, a culture whose other works have been buried under millennia of desert sand or swallowed by the shifting Nile Delta. Their society may have been organized around a powerful spiritual or astronomical purpose, one that justified and directed this generational labor. After the climate changed and their world dried up, this culture could have dispersed, migrated, or declined, their specialized engineering traditions fading into legend before the rise of dynastic Egypt. The skills required to carve the Sphinx might have been lost, only for basic quarrying and stone working to be rediscovered or reinvented centuries later by the early Egyptians. The other, more speculative possibility is that the knowledge itself was not native but imported. Could the Sphinx represent a transfer of technology from elsewhere, from a civilization even older and now perhaps lost to the rising seas or geological upheaval? This idea ventures into the realm of what historians call hyperdiffusionism, the notion that major cultural advances radiate from a single, ancient source. While mainstream scholarship is deeply skeptical of such claims, the sheer unexpectedness of the Sphinx's engineering in a Neolithic context keeps the question alive in the realm of fringe theory. It asks us to consider whether our map of ancient human achievement is missing entire continents of forgotten innovation. Ultimately, the monument becomes a silent judge of our assumptions about progress. We tend to view technological history as a steady, upward climb. But what if it is not a smooth line, but a series of peaks and valleys? What if advanced knowledge can be gained, concentrated in a specific time and place for a specific purpose, and then fragmented or forgotten? The Sphinx does not provide answers, but it stands as a permanent, stone-hewn question mark. It challenges the conventional, linear model of cultural progression, suggesting that the path from stone tools to pyramids may have had a forgotten, monumental waypoint, a masterpiece that forces us to reconsider just how deep the roots of human ingenuity truly go. The profound age suggested by the stone forces us to reconsider the very meaning of the statue. If the Sphinx is not a product of dynastic Egypt, then its original identity is not a pharaoh's portrait, but something far more ancient and perhaps more universal. The traditional interpretation is powerful and elegant. In the Egyptian context, the lion was a symbol of the sun god Ra and of the king's own protective, regal power. The human head upon a lion's body represented the pharaoh's divine intellect ruling over the brute strength of nature. This symbolism fits perfectly within the known religious framework of the Old Kingdom. But if the core sculpture predates that framework by millennia, then this meaning becomes a later addition, a brilliant reinterpretation of a pre-existing form. We must then ask, what did this colossal lion represent to its original creators? One compelling avenue of exploration leads us from the sands of Giza to the stars above. A controversial yet persistent theory in the field of astroarchaeology proposes that the Sphinx was not just a solar symbol, but a precise celestial marker. The argument centers on a phenomenon known as the precession of the equinoxes. This is the slow, 26,000-year wobble of Earth's axis, which causes the backdrop of stars visible at the spring equinox to gradually shift over centuries. Today, the sun rises against the constellation Pisces on the first day of spring. 2,000 years ago, it was in Aries. According to this theory, if we rewind the celestial clock far enough, we find a remarkable alignment. Around 10,500 years before the Common Era, the sun on the spring equinox would have risen directly in front of the constellation Leo, the lion. In this epoch, the Sphinx, gazing due east, would have been staring directly at its own celestial counterpart at the moment of the sun's rebirth. Proponents suggest the monument could have been a monumental marker for this age of Leo, a stone lion on the ground mirroring the lion in the sky, commemorating a specific grand cycle of time. This idea, while not accepted by mainstream Egyptology, attempts to provide a purpose for the Sphinx that transcends any single civilization. It frames the monument not as a portrait of a king, but as a chapter in a much longer story written in the stars, a story about cosmic cycles and humanity's attempt to anchor itself within them. The geological evidence of water erosion from a wet period that coincides roughly with this earlier date gives this astronomical theory a tantalizing, if speculative, foothold in physical reality. It proposes that the Sphinx's original purpose was fundamentally astronomical and mythological, a permanent observatory and a symbol of a world age. Then, as millennia passed and the stars slowly drifted, the specific knowledge of that alignment may have faded. When a new culture arose on the Nile, they encountered this awe-inspiring leonine figure facing the rising sun. They naturally integrated it into their own solar worship, seeing in its weathered form a manifestation of their sun god and a perfect vessel for their king's divine authority. They recarved the head, adopted the guardian, and in doing so gave an ancient cosmic timekeeper a new name and a new earthly king. This reinterpretation does not diminish the Egyptian achievement, but rather layers it. It suggests that the genius of the pharaohs may have included a profound act of cultural archaeology, recognizing the sacred power of a relic from a lost age and weaving its ancient mystery into the fabric of their own civilization. The Sphinx, in this light, becomes a palimpsest of meaning, its stone bearing the intentions of two different worlds separated by thousands of years, yet united by a shared gaze toward the horizon and the heavens. Yet for all its geological intrigue, this older Sphinx theory remains firmly outside the halls of mainstream Egyptology. The reaction from most professional archaeologists is not one of intrigue, but of profound skepticism. Their position is built not on reading the stone, but on reading the ground, on the tangible, physical evidence left behind by human activity. Their argument is powerful in its simplicity. If a sophisticated culture capable of carving the Sphinx existed at Giza 7,000 or more years ago, where is the rest of their world? A project of such staggering scale does not appear in a vacuum. It would have required a permanent or semi-permanent workforce, a supporting settlement with housing, workshops, and storage. It would have generated a mountain of material evidence. We should be finding their tools, the specific stone hammers and copper chisels used for such precise work. We should be finding their pottery shards, their hearths, their burial sites, the everyday debris of a community that lived and labored there for generations. To date, after more than a century of intensive excavation across the Giza plateau, not a single artifact, not one piece of pottery or tool, has been conclusively dated to that proposed wet Neolithic period in direct association with the Sphinx's construction. The archaeological record at Giza is rich and deep, but it speaks consistently of the Fourth Dynasty and later periods. From the perspective of traditional archaeology, an absence of evidence is a critical form of evidence itself. It suggests the builders were exactly who the historical record says they were, the Egyptians of the Old Kingdom, whose material culture is found everywhere around the monument. The erosion, they argue, must therefore be explained within that established timeline. They point to the complex, layered nature of the local limestone, where soft and hard strata react differently to any weathering agent. They emphasize the undeniable role of rising and falling groundwater from the nearby Nile, a process that could cause severe salt crystallization and subsurface weathering at the monument's base for centuries after its construction, creating those deep hollows without requiring an older age. This is more than a technical disagreement over erosion patterns. It represents a fundamental clash of intellectual disciplines. On one side, geology operates in deep time, reading broad environmental stories written in rock formations and weathering profiles. Its evidence is the stone itself, and its conclusions can point to vast, sweeping timelines. On the other side, archaeology is a science of context. It builds its narratives painstakingly from the placement of a potsherd, the orientation of a wall, the style of a carving. It requires a web of interconnected evidence, artifacts in situ, to confirm a date or a culture. A geological reading of the Sphinx to an archaeologist is like hearing one note from a symphony and trying to describe the entire composition. Without the supporting artifacts, the cultural context, the full orchestra of evidence, that single note, no matter how compelling, cannot define the piece. This debate, then, is not a petty academic squabble. It is a necessary and healthy tension at the frontier of knowledge. It forces both sides to sharpen their arguments, to look harder at their assumptions, and to consider that the truth about our distant past may be more complex than any single methodology can reveal on its own. The Sphinx sits silently at the center of this intellectual crossroads, a riddle that challenges not just our timeline, but our very methods of uncovering history. This intellectual stalemate between stone and artifact reveals a deeper truth about how we explore history. The Sphinx controversy is not merely a disagreement over dates, it is a clash of two very different ways of seeing the world. Geologists are trained to read the autobiography of the Earth, written in the language of mineral composition, sedimentary layers, and weathering profiles. Their evidence is the rock itself, and its story unfolds across vast geological time. Archaeologists, in contrast, are detectives of human activity. They reconstruct history from the things people left behind, from the placement of a wall to the style of a pot handle, building a narrative from a mosaic of cultural clues. These disciplines often operate in separate spheres with different methodologies, peer review circles, and even technical vocabularies. The Sphinx sits precisely at the intersection of these two worlds, and its riddle cannot be solved by one field alone. A true resolution demands something more difficult than new evidence. It requires a new conversation. We need a collaborative framework where these separate languages begin to translate for one another. Imagine a research project designed from the ground up for this purpose. Advanced, non-invasive ground-penetrating radar surveys could map subsurface anomalies, but their data would be interpreted not in a vacuum, but alongside archaeologists who understand the plateau's construction phases. Careful, minimally invasive core drilling could extract samples from the Sphinx's deepest weathering channels, but those cores would be analyzed by both geochemists studying water history and archaeologists looking for microscopic tool marks or fill material. Sophisticated petrographic analysis could definitively identify the weathering agents, but its results would be weighed against the complete archaeological record of tool technology and settlement patterns from the proposed eras. This is not about one side proving the other wrong. It is about constructing a unified interpretation that respects both the stone's physical testimony and the context of human presence. The Sphinx, therefore, becomes more than an ancient monument. It is a powerful case study for the future of historical inquiry. It reminds us that our deepest past is not compartmentalized. The story of humanity is written simultaneously in the climate that shaped the landscape and in the potsherds left by the hearth. To recover that full story, we must build bridges between the humanities and the hard sciences, allowing each to inform, challenge, and ultimately enrich the other. Only through this kind of interdisciplinary dialogue can we hope to hear the complete whisper of time, a whisper that carries both the memory of ancient rain and the echo of forgotten voices. The Sphinx does not have to stand alone as a geological mystery. To truly understand its weathered face, we can look outward to other ancient stone sentinels around the world. These monuments form a kind of global laboratory, each one recording a unique conversation between human ambition and the relentless elements. Take Göbekli Tepe in southeastern Turkey, for instance. This staggering complex of carved T-shaped pillars arranged in circles was intentionally buried around 11,000 years ago. Its stone, a form of limestone, was protected for millennia, preserving sharp reliefs of animals and symbols. When excavated, the surfaces showed weathering, but of a specific kind, related to its local semi-arid climate and the protective fill. Then there are the standing stones of Nabta Playa, deep in the Egyptian Sahara. Dated to around 7,000 years ago during the tail end of the Green Sahara period, these megaliths were erected by cattle-herding peoples in a then savanna environment. Their weathering tells a story of that transitional climate, marked by both water and wind before the desert fully reclaimed the land. Each of these sites presents a distinct weathering signature, a fingerprint created by the specific type of rock, the local rainfall patterns, temperature swings, and even the chemical composition of the soil and groundwater. A geologist examining them learns to read a dialect of time. The pitting on a granite menhir in Brittany speaks of freeze-thaw cycles. The soft, rounded contours of a sandstone temple in Cambodia whisper of relentless tropical humidity. By building this global database of erosion patterns, researchers can begin to calibrate their models. They can ask more precise questions. Does the deep, vertical channeling on the Sphinx enclosure match the profile of a limestone structure exposed to 5,000 years of sporadic desert thunderstorms? Or does it align more closely with the damage seen on surfaces known to have endured 2,000 years of consistent, heavy seasonal rains? This comparative method moves the discussion beyond a binary argument about the Sphinx. It reframes the question. Instead of simply asking if it looks old, we can ask what specific kind of old it looks like. Does its weathering signature fit comfortably within the established spectrum for 4th millennium BCE Egypt, or does it represent an outlier, a pattern that demands a different environmental history? Placing the Sphinx within this worldwide context doesn't automatically prove an older age, but it provides a crucial frame of reference. It turns a solitary riddle into a single data point in humanity's long struggle to make marks upon the earth that outlast the centuries, a struggle written in stone and slowly rewritten by the sky. The stone has told its story, but the earth beneath it may hold the final chapter. To move beyond surface interpretations, we need to see inside the plateau itself, and the key lies in a suite of remarkable, silent technologies. These are not tools for digging, but for listening and seeing through solid rock. Ground-penetrating radar, or GPR, is like giving the earth an ultrasound. It sends pulses of radio waves into the ground, which bounce back when they hit changes in density, revealing hidden structures, voids, or layers. Electrical resistivity tomography, or ERT, works on a different principle. It measures how easily electrical current passes through the subsurface. Water, solid rock, and empty cavities all conduct electricity differently, allowing this method to paint a detailed picture of underground features. Then there is the most exotic of the group, muon radiography. This technique uses cosmic rays, natural subatomic particles that constantly rain down from space. These muons pass through matter, but denser materials absorb more of them. By placing detectors around a structure, scientists can measure the muon flux from different angles, creating a three-dimensional density map, essentially an X-ray for pyramids and hills. Imagine deploying these technologies in a coordinated, international survey of the Sphinx and its enclosure. A fleet of sensors moving in precise grids could build a comprehensive digital twin of the entire subsurface area. This would not be guesswork, it would be a map. Such a survey could definitively answer questions that have fueled speculation for generations. Are there chambers beneath the pores, as some early scans hinted? Do networks of natural fissures show signs of human modification, suggesting ancient water channels or access tunnels? Most importantly, it could reveal the monument's foundational relationship with the plateau. Is the Sphinx a solitary sculpture on a solid base, or is it the capstone of a much more complex, integrated subterranean architecture? This data would provide a new physical framework for the entire debate. It would shift the conversation from interpreting weathered surfaces to analyzing a three-dimensional blueprint. Proponents of an older Sphinx might point to unexpected, deep foundations or water-worn cavities sealed by later construction. Defenders of the traditional timeline could find a reassuring lack of major anomalies, confirming the monument as a magnificent but essentially straightforward carving. Either way, the mystery would no longer rely solely on what we can see, but on what we can now prove lies hidden in the dark. The promise of these non-invasive tools is a future where we can seek answers without causing harm, listening to the whispers of the deep earth to finally understand the giant that stands upon it. This pursuit of hidden knowledge brings us to a delicate crossroads. The very technologies that could unlock the Sphinx's deepest secrets also present a profound ethical dilemma. Every proposed study, from advanced scanning to the most carefully considered core sample, must be measured against an unshakable principle: preservation first. The Great Sphinx is not merely an archaeological site. It is a fragile, living monument to human history, a piece of world heritage that belongs to all generations, past, present, and future. The stone has endured for millennia, but its patience is not infinite. The central question becomes, how do we responsibly balance our burning curiosity with our solemn duty to protect? The quest for answers must never become a threat to the wonder itself. This means any research program must adhere to a strict ethical framework. It must be minimally intrusive, designed to gather maximum data with the absolute smallest physical impact. It must be scientifically rigorous, with clear goals and methodologies peer-reviewed by experts from both geology and archaeology. Most critically, it must be conducted in full partnership with, and with the explicit consent of, the Egyptian authorities who are the site's stewards, and in dialogue with the global community of scholars. This is not about ownership but about shared guardianship. A single, unauthorized drill hole for a sample, no matter how well-intentioned, could damage irreplaceable stratigraphic layers or compromise the monument's structural integrity. The goal is to listen to the Sphinx, not to speak over it. True understanding will come from a collaborative, careful, and respectful conversation with the stone, one that ensures this silent guardian continues its watch for thousands of years to come, its mysteries perhaps better understood, but its majestic presence utterly preserved. The Sphinx's unanswered questions have not remained confined to academic journals. They have spilled over into the vast, vibrant, and often chaotic realm of popular imagination. When official history presents a puzzle with missing pieces, the human mind instinctively tries to complete the picture. the monument's sheer age, its silent gaze, and the unresolved erosion debate have made it a blank canvas for some of the most sweeping alternative narratives in modern culture. You will find theories linking it to the lost continent of Atlantis, suggesting it is a repository of ancient wisdom from a forgotten global civilization. Others propose it functions as a precise astronomical clock or even a warning marker, built by a sophisticated precursor culture to alert future generations to a recurring cosmic cataclysm, like a comet strike or a polar shift. These stories are compelling on an epic, almost mythological scale. They transform the Sphinx from an archaeological subject into a character in a grander, more mysterious human saga. It is crucial, however, to draw a clear line between different types of inquiry. On one side, you have the evidence-based geological hypothesis, which uses observable data from the stone and correlates it with known climatic history. This is a scientific argument, open to testing and peer review, even if it challenges conventional timelines. On the other side lies speculative lore, which often starts with a captivating premise but builds upon intuition, symbolic interpretation, or selective evidence rather than systematic, reproducible analysis. The endurance of these alternative tales is not a sign of their truth, but a testament to the profound fascination the Sphinx commands. It reveals something fundamental about us. We are pattern-seeking creatures, deeply uncomfortable with historical silence. When the material record is incomplete, we are driven to weave narratives that provide meaning, connection, and a sense of lost grandeur. The gaps in the official story of Giza have created a perfect vacuum, and nature, along with human curiosity, abhors a vacuum. Into that space flows a mixture of legitimate questioning, bold hypothesis, and pure imaginative speculation. This interplay is not necessarily negative. At its best, it pushes mainstream scholarship to re-examine its own assumptions and to communicate its findings more clearly to a public hungry for wonder. It reminds us that history is not just a collection of facts, but a story we tell about who we are and where we came from. The Sphinx, sitting at the crossroads of geology and legend, challenges us to hold two ideas in balance, to appreciate the rigor of science while understanding the powerful human need for myth. Our journey through stone and time leads us to a final, grounding question, one that brings us back from the stars of speculation to the very sand beneath our feet. What does the future hold for this ancient guardian, and how will we choose to seek its truths while ensuring its survival for the centuries to come? The story told by the stones begins to form a startlingly clear picture when we listen to all its voices at once. Let's step back for a moment and weave these separate geological threads into a single, coherent narrative. First, the deep vertical channels and rounded hollows carved into the Sphinx enclosure are a signature. They are the unmistakable handwriting of moving water, of rainfall cascading over exposed limestone for century after century. Second, the climate record is unequivocal. That kind of prolonged, heavy rain last fell on the Giza plateau thousands of years before the pharaohs, during the Green Sahara period that faded by around 3,000 years before the Common Era. Third, the monument itself wears its history unevenly. The dramatic contrast between the deeply weathered body and the less eroded head points to a much longer period of exposure for the core structure, as if the lion's form stood alone for ages before receiving its familiar face. And fourth, the ancient restoration blocks at its base act as a seal in time. They prove that the severe erosion we see today was already complete, a fait accompli, when the Old Kingdom builders arrived to make their repairs. Individually, each of these points invites a question, but when you braid them together, they form a strong and startling rope of evidence. This synthesis suggests a sequence of events that rewrites the traditional story. It proposes that the core body of the Great Sphinx was excavated and shaped not in the dry era of pyramids, but in a much earlier, wetter age. It stood as a sentinel through the slow death of the Green Sahara, its surface being sculpted by the very rains that were retreating south. Then, as millennia passed and the desert solidified its grip, the sand slowly began to claim it. By the time a new civilization arose along the Nile, the monument they found was not a new project, but an ancient, crumbling relic. They saw its power, restored its damaged base, and likely recarved its head, grafting their own royal identity onto a guardian from a world they had never known. This is not a fringe fantasy, but a logical model built from observable geology and established climatic history. It is a powerful alternative timeline that does not dismiss the achievements of dynastic Egypt, but instead places them in a new light, as brilliant inheritors and restorers of a legacy far older than their own. This synthesis is not the final word, but it is a compelling invitation to look at this familiar monument with completely new eyes, to see not just a statue, but a stone chronicle of a lost chapter in the human story. Yet this geological narrative meets its most formidable obstacle not in the stone but in the soil. The ground around the Sphinx is stubbornly silent. For a project of such staggering scale, we would expect to find the bustling echoes of its creation, the tools, the homes, the broken pottery of the workers, the very debris of a civilization in action. According to the archaeological record as it currently stands, none of that material exists from the proposed wet Neolithic period at Giza. This absence is not a minor detail. It is a deafening silence that forms the core of the counterargument. How can we speak of an advanced, monument-building culture when the Earth yields no trace of their daily lives? Reconciling the voice of the geology with the silence of the archaeology requires us to think creatively about what evidence might look like and how it could vanish. One compelling theory looks to a different model of social organization. Imagine not a centralized empire with cities and bureaucracies, but a sophisticated pastoralist society. During the Green Sahara, vast savannas supported herds and the communities that followed them. These groups could have been semi-nomadic, coalescing at specific, sacred times of the year at powerful ritual centers like Giza. Their monumental work might have been a seasonal, generational pilgrimage, a communal act of devotion that did not require a permanent, sprawling settlement. After carving the Sphinx, they would have packed their tents, their finely made but portable tools, and moved on with their herds, leaving behind little more than the monument itself. Their archaeological footprint would be faint, like tracks on grass, easily erased by time and the encroaching desert. Their most lasting legacy would not be in middens or house floors, but in the bedrock they shaped. Another possibility involves not the absence of evidence, but its active removal. Consider the sheer scale of construction during the Egyptian Old Kingdom. The pyramids, temples, and causeways of Giza required an astronomical amount of stone. Where did it all come from? The plateau itself was the primary quarry. It is entirely plausible that the later dynastic Egyptians, in their feverish building campaigns, systematically quarried away every trace of any earlier temporary settlements that might have huddled near the Sphinx. They would have scraped the ground clean to access fresh limestone, dismantling any crude stone huts, gathering every last tool and potsherd, and grinding it all into the foundations of their own grand projects. In this scenario, the evidence of the older builders was not lost to time. It was literally recycled into the pyramids. Their camp became part of Khufu's temple, their history physically absorbed by the civilization that came after. This synthesis asks us to expand our definition of an archaeological record. Perhaps the evidence is not missing, it is simply not in the form we expect to find. The Sphinx itself is the artifact, its weathering profile is the data, the arrangement of the restoration blocks is the context. This shifts the search from looking for the builder's trash to reading the builder's masterpiece as a primary document. It remains the largest and most legitimate hurdle for the revised chronology. a profound puzzle where the stones speak a compelling language of water and time, while the traditional artifacts for now remain silent. This silence is not an end to the inquiry, but a challenge to our methods, urging us to listen more carefully to the stories written not in objects, but in the very skin of the earth. That silent stone lion could hold a key to a much larger story. If the geological whispers are correct, and the Sphinx truly predates the pharaohs by thousands of years, its implications do not stop at the edge of the Giza plateau. This single monument, if redated, would send a tremor through our entire understanding of early human history. It would force us to redraw the map of cultural development, not just for Egypt but for our species. The standard historical model presents a relatively linear progression. After the last ice age, humans transitioned from nomadic hunter-gatherers to settled agricultural communities. From these early villages, over millennia, grew the first cities, states, and eventually, the great civilizations of the ancient world, with their writing, monumental architecture, and complex social hierarchies. This process is seen as a slow, cumulative climb. The Sphinx, as traditionally dated, fits neatly into this model as a crowning achievement of an already mature, state-level society in the Nile Valley. But if the Sphinx is a product of a much earlier, wet Neolithic period, it becomes a staggering anomaly. It would represent a monumental leap in scale and ambition appearing seemingly out of sequence. This suggests that the human capacity for large-scale, coordinated artistic and engineering projects may have manifested far earlier and in different social contexts than our textbooks allow. We would have to confront the possibility of a sophisticated, symbolically rich culture flourishing during an era we primarily associate with simple village life, polished stone tools, and the earliest domestication of plants and animals. The Sphinx would no longer be an Egyptian invention, but a Neolithic one. Its builders would belong to a world that existed long before the concept of Egypt was even born, a world whose name and language are utterly lost to us. This reframes the monument from a national symbol to a global artifact, a piece of a deeper, more widespread puzzle about human potential. It challenges the very notion of prehistory as a quiet, simple prelude, suggesting instead that it may have contained episodes of concentrated cultural flowering that later faded or were disrupted, their knowledge preserved only in stone and legend. The ripple effect touches every ancient site. It invites us to look at other megalithic wonders around the world with fresh eyes. Places like Göbekli Tepe in Turkey, with its astonishingly early stone circles, or the massive temples of Malta, already push the boundaries of what we thought possible for Neolithic societies. A revised age for the Sphinx would place it in a similar, breathtaking category, not as an outlier but as part of an emerging global pattern. It hints that the drive to build on a colossal scale, to encode meaning in architecture aligned with the heavens, and to leave a permanent mark upon the landscape, might be a fundamental, recurring impulse in human societies, one that can emerge under the right conditions of environmental stability, spiritual vision, and social cohesion, long before the rise of kings and empires. This does not diminish the later achievements of dynastic Egypt or any other classical civilization. Instead, it deepens their roots. It suggests they were not the first dawn of human complexity, but perhaps a brilliant second sunrise, building upon the forgotten foundations of those who came before. The Sphinx, in this light, becomes more than a mystery to be solved. It transforms into a profound question about the rhythm of human history itself. Are we looking at a smooth, upward trajectory or a story of peaks and valleys, of knowledge gained, lost, and rediscovered across the vast expanse of time? The answer, written in water-worn stone, waits for us to learn how to read it fully. The profound questions surrounding the Sphinx demand a new kind of conversation, one that moves beyond debate and into deliberate, shared discovery. To resolve a mystery of this scale, we need more than isolated studies or competing interpretations. What is required now is a formal, collaborative research initiative, a grand project designed from the ground up to be transparent, multidisciplinary, and definitive. Imagine a unified team, not of rivals but of partners. Geologists who read the language of rock would work alongside climatologists modeling ancient weather patterns. Archaeologists expert in material culture would consult with engineers specializing in non-destructive testing. Their shared mandate would be clear and ambitious: to apply the full suite of modern investigative tools to the Sphinx and its immediate surroundings, creating a comprehensive digital and physical portrait of the monument we have never before possessed. This would begin with a coordinated geophysical survey. Advanced ground-penetrating radar and electrical resistivity tomography would map the subsurface in high resolution, searching for chambers, tunnels, or foundational anomalies. Three-dimensional laser scanning would create a perfect digital model of every erosion channel and weathering profile, allowing for precise measurement and comparison. Most importantly, carefully planned, minimally invasive core samples could be taken from key locations, such as the floor of the enclosure and from behind the ancient restoration blocks. These cores would be the Rosetta Stone of the debate. Petrographic analysis could definitively identify the chemical signatures of weathering, distinguishing between water dissolution and wind abrasion from within the stone itself. Radiocarbon dating of any organic material trapped in ancient mortar or sediment layers could provide absolute chronological anchors. The goal is not for one side to win, but for the fog of uncertainty to lift. The outcome would be a definitive, shared dataset, a common body of evidence that all scholars, regardless of their starting hypothesis, could use to test their models. This transforms the dynamic from a clash of conclusions into a collaborative puzzle-solving session focused on a shared, awe-inspiring mystery. It respects both the stone's physical testimony and the need for archaeological rigor, creating a bridge where currently there is often a divide. Such an undertaking would be complex, requiring international funding, meticulous planning, and the full cooperation of cultural authorities. Yet the potential reward is nothing less than a new chapter in our understanding of human antiquity, written not by speculation, but by the harmonious convergence of science and history. The Sphinx has waited for millennia. Perhaps it is waiting for us to finally ask the right questions together. The final verdict on the Sphinx age is not written in any book. It rests instead in the careful balance of evidence each of us chooses to weigh. After this journey through stone and climate, where does your own curiosity settle? Does the profound water erosion and the climatic timeline convince you of a much older monument, a relic from a green world? Or does the powerful silence of the archaeological record, the absence of tools and settlements from that deep time, anchor you to the traditional pharaonic story? This is not a puzzle with a simple answer waiting at the back of a textbook. It is something far more valuable, a living demonstration of how history is actually made. You have just witnessed a masterclass in critical thinking. Two rigorous disciplines, geology and archaeology, have presented their best cases using their own languages of proof. One reads the autobiography of the Earth in weathered limestone, the other reconstructs human activity from pottery and placement. Their disagreement is not a failure, but a fundamental part of the process. It forces us as observers to become active participants. We must learn to evaluate different kinds of evidence, to understand the inherent biases of each field, and most importantly, to sit comfortably with the tension of not knowing for sure. This is where real learning begins. History is not a collection of static facts handed down from on high. It is an ongoing interpretation, a continuous conversation between the past and the present. Every generation looks at the same artifacts, the same stones, and asks new questions with new tools. The story of humanity is constantly being edited, not because the past changes, but because our understanding of it deepens. You are now part of that conversation. The Sphinx has done its job perfectly, not by giving us an answer, but by giving us a better question. It challenges us to move beyond simply asking how old is it, and to grapple with the more profound inquiry, how do we know? It invites us to scrutinize the sources, to question the narratives we have inherited, and to remain intellectually humble and open. The true legacy of this ancient guardian may not be a date, but a mindset, a reminder that the most fascinating chapters of our story are often those written in the gaps between what we can prove and what we can imagine. That silent, knowing gaze across the desert holds its power precisely because it offers no easy answers. The Sphinx captivates us not in spite of the debate, but because of it. The very possibility that it might be a relic from a lost age, a sentinel from a green world we can scarcely picture, is what elevates it from a historical artifact to a timeless icon. It stands as the world's most magnificent cold case, a detective story written in geology and whispered in legend, where the clues are weathering patterns and the suspects are entire forgotten cultures. This unresolved nature is not a flaw in our understanding. It is the engine of our fascination. It is what compels geologists to take new core samples, archaeologists to re-examine old dig sites, and engineers to design ever more sensitive scanning devices. The mystery itself is a catalyst, pushing the boundaries of science and scholarship in a relentless pursuit of context. It forces disparate fields to talk to one another, to translate between the language of stone and the language of artifacts, creating a richer, more interdisciplinary conversation about our shared past. On a human level, this enduring puzzle taps into something fundamental within us. We are storytellers by nature, and the Sphinx presents a narrative with a breathtaking gap. Our minds instinctively rush to fill that silence, weaving tales that range from the rigorously geological to the wondrously speculative. This creative engagement, this collective act of wondering, is a testament to the monument's profound grip on the human spirit. It transforms every visitor from a passive tourist into an active participant in an ongoing investigation that spans generations. Ultimately, the Great Sphinx of Giza teaches us that the most important chapters of history may not be the ones we have confidently written, but the ones we are still learning how to read. Its true legacy may not be a definitive date or a builder's name, but a permanent state of questioning. It reminds us that our past is not a closed book, but a living, breathing dialogue with the evidence left behind. The greatest monuments are not those that simply tell us who we were, but those that compel every new generation to look upon them and ask with fresh eyes and new tools who we might have been. In its majestic, weathered silence, the Sphinx does not give answers. It gives us a far greater gift, an invitation to keep searching. The story of the Sphinx is ultimately a story about how we listen to the past. Our journey has taken us from the microscopic world within a grain of limestone to the sweeping climatic shifts that turned a green Sahara into a desert, tracing a geological argument that points toward a shadowy, pre-pharaonic age for this colossal guardian. The debate, of course, is not a closed case. Respected scholars on both sides bring powerful evidence to the table, from the silent testimony of missing artifacts to the compelling voice of weathered stone. Yet the patterns of water erosion and the stark tale told by differential weathering stand as a formidable, persistent challenge to a timeline we once thought was settled. This unresolved tension, however, is not a failure of our inquiry, but its greatest success. It means we are looking closely, thinking critically, and asking better questions. Whether the evidence has convinced you or you find yourself leaning toward the traditional narrative, the investigation itself transforms our experience of the monument. The Sphinx is no longer just a static image on a postcard. It becomes a living document, its surface a page inscribed by wind and water, its form a sentence in the long, slow language of earth and time. It guards its ultimate secrets as fiercely as ever, but perhaps we are finally learning the right way to listen. We are beginning to hear the story its stones have been whispering across the millennia, a story of forgotten rain, of a green world lost to sand, and of the enduring human desire to make a mark that outlasts the ages. If this exploration has reshaped how you see this ancient wonder, or the deep roots of history itself, share your thoughts in the comments below, and subscribe to join us as we continue to journey deeper into the enduring mysteries of our world.